Here to introduce assignment 0. And let me show you how to first open the assignment. So if you are at our syllabus page on Canvas, you can click here on assignments and then assignment 0, vector library. So here's the description of our assignment. All our assignments are going to follow similar instructions, which means they're going to have similar sections, starting with objectives. So for instance, the objective of this assignment is to extend the matrix library provided by the textbook. And you're going to extend it to support vector operations, such as addition, subtraction, multiplication, cross product, dot product, and so on. So the idea of this assignment is for you all to learn how to create object-oriented graphics projects in libraries, how to draw to a canvas element using a 2D context, and the major idea being reviewing fundamental concepts of linear algebra that you're going to use throughout this whole course. So the textbook provides a matrix library that is called quantmatrix.js. So if you read the book, especially like starting on chapters 3 and 4, we won't deal with that for now, but you'll see later that there is a quantmatrix.js library provided by the authors of the textbook. We're going to use that. However, this library is somehow limited because it doesn't provide a lot of useful vector operations. And so we thought it would be useful for you all to start working with JavaScript and to review your linear algebra concepts by creating this library that you use later for your assignments as well. So let's start on the instructions. So for every assignment has a list of bullet points numbered. For example, this one has like number 1, number 2, number 3, and so on. Those are bullet points that are also rubric points. So this means that if you finish this part here of the assignment, you get 1 point. Okay, and to make sure you finish it right, you're gonna get expected results here at the bottom, so you can compare with your own solutions, and if it's looking similar, most likely you're gonna get full credit on that bullet point. Okay, so let me kickstart you on this assignment. So the first bullet point that says set up the draw rectangle example from the book with our matrix library. So this means that we're going to grab this example from the book and our own version of the quant matrix library, which I'm going to talk about a little bit later. So here you can follow these bullet points, and the first task is to download the draw rectangle example from the book, right? And so this example is composed of two files, draw rectangle and draw.js. Okay, so if you look at this page in the book, right, I have the book right here. So I'm gonna go to page 11. And this is the example. So actually the example is gonna look like this. It's just a blue rectangle on an HTML canvas element. And here you have the HTML source code that renders this example. You're going to need as well a simple JavaScript file that is actually described here that you can grab exactly from here. Okay, so page 13. So I'm going to show you just how to do it for this example, right? So for most of the examples in the book, the authors already have a website that you can grab the examples from. And I have the page open here. Right, so this is the book's webpage. And if you look down here, you're going to have a list of examples already here, so you can easily click on them and study them. So we are here for this assignment, we are talking about chapters 1 and 2, but specifically chapter 2, if you click here, you see that you have already some examples. Unfortunately, as you see here, there is no draw rectangle example. You have a hello canvas that is just a black canvas. And then all these examples are already examples using WebGL. We are not going to talk about these in this first assignment. So you have this example, but unfortunately this one is not there. This means that I recommend you typing in this code for the first time, especially because this is might be your first contact with HTML and JavaScript. So because of that, I do recommend that you open a text editor like this and then type that whole code in. And don't don't copy it, just actually type the whole thing. So you kind of ask yourself what each tag is doing, right? We talked about this in our lab section. We talk about simple HTML examples in our first lab section. So if you want to learn more about that, you can refer to that video. So yeah, so keep typing in, and once you're done, you should save this file. Let me just complete it, body. And then once you're done, you should kind of understand exactly which one of these lines are doing. Okay, so you save this, and I recommend you, so then creating a folder. Let's call this, I'm gonna call this for now uh, assignment 0. Okay, so inside of assignment 0, you can call this assignment 0.html. Okay, then once you do that, of course, you're gonna have the whole thing here. You're gonna have this whole code there, right? You're gonna have this whole code here. Once you have all of this, then you should go read these pages and understand what everything is doing, specifically what this canvas element is doing. This is a very important HTML element that we're going to use for rendering our graphics. And second part is to grab this draw rectangle.js file. So the source code is here. This is the source code for the file. Similar to the HTML, I recommend you making a new file. You can call it assignment0.js. Right. And then type it in. Type it in exactly what you see in the book. Like draw rectangle.js. My function main. Then retrieve canvas element. Canvas element. The var canvas, right, equals document. I'm gonna finish this one. Get element by ID. So we talked about this specifically the document get element by ID function. We talked about it in our lab section as well. So once you're done, you should have this whole thing here, right? Typed in. Yeah, fortunately. So I'm gonna erase this line numbers. So you should have this whole code in here. Okay. And as you can see, this is a main function. I won't explain these lines one by one because the book is doing that, but you have this main function that is called in your HTML here. So if you look at line number 8 here, where the body is defined, there's an argument called onload, or an attribute called onload, and it says equals to main. This means that when the whole page is loaded, it's going to automatically call this main function. However, for the HTML to be able to do that, it has to know this main function. Right? How does it know it? It knows it because we are loading that script right here. Note that the book calls it drawRectangle.js, and we just named it assignment0.js, right? So I have to make sure that I change this to assignment0.js as well, because I want to load the right file, okay? Also, remember that we are loading the script here because in the script, you're gonna get access to the canvas element, which is exactly this line here. This line number 5 is trying to access the canvas element with this ID, right? And this is the ID of the canvas. So because of that, we need to load our script after defining the canvas, okay? And with that, we should be able to run that simple example. So if I go to my project folder here, where is it? I think it's here, right? This is where I saved my files. So if I open it, I get the example working. Okay. So this is described all here. The only remaining thing is to download the library. Okay. So this library here is a modified version of the original Quant matrix that we created. The main difference here, I'm going to open this library so you see. So this library contains or has 3 classes in it. It has a class vector3, which is you're going to extend and implement most of the functions. And you have this very simple vector4 class. We won't talk about it right now, but as you can see, there's only a constructor in there, right? In our in our first lab section, we also talked about classes in JavaScript. So refer to that if you want to learn more about classes. And you see that the most most of the functions from this library they come from this matrix4 class. And this is a very complete class that has, for example, multiplication function. You can create, you can create a function, create a matrix 4 by 4 with this using this constructor. You can set that matrix to be an identity. You can set this matrix to get values from an array. You can multiply this matrix by another matrix. You can concatenate it with another matrix. You can multiply it by a vector 3. You can multiply it by a vector 4. You can transpose, and so on and so forth. You can set it as an inverse of another matrix. So we're going to use this more in assignments 2 and 3. But for now, what you're going to do is you're going to extend this class here, vector3. So this library already gives it to you, the constructor function and the set function. Your job is to implement each one of these functions here. Add, sub, div, mul, dot. Note that this is a static function, and the cross product function is also a static function, as well as magnitude and normalize. Okay, so your job your main job in this assignment is to implement all these functions here. And note that we already give to you a return statement on each of these functions. This means that we want you to return the instance of the vector that you are operating on always. So if you have a vector v1 and a vector v2, for example, and you call v1 dot sub and you pass v2 here, what you're going to do is you're going to subtract v1 by v2 and return v1. And in this case, this is going to be referring to v1. Okay? So always return the instance of the vector, return this. So keep this return here for all these functions. For the static versions, like the dot one, so static versions, static functions are functions that you call using the class and not an instance of that class. So because of that, then you're gonna have to create a scalar in this case, because dot product returns a scalar, and we started at 0, but it's your job to modify this line to return the correct dot product between other one and other two, and those are two vectors. And cross product also, now you have to return a vector because the result of a cross product is a vector. So we already have an instance of a vector here for you, and your job is to modify this line to calculate the correct cross product. Okay, so there's more details about each of these tasks here on the assignment, but let me show you how to download this. So when you click here, you can just simply copy this whole thing, create a new file, paste it exactly like that, and then save it. And let's create a new folder here called lib. And I'm going to call this, let's keep it the same name, Q1 matrix csc160.js. Okay. So if I save it like that, now I get all my code highlighted. And finally, the last thing that I have to do, so make sure you got the library here. Okay, now it's here in your project. Now it's our assignment 0 and all the files. So last thing I have to do is load that library in my code. So now it's under lib Q1 matrix dot. Oh, I type it like it should be CSC dash. Okay. So CSE 160.js. So now you're loading that library from our library directory. I'm going to type this, actually create a comment here saying load libraries. Later, we're going to have more libraries, so I'm going to just leave it like this. And okay, so now let's refresh our page. And I'm going to open my console here, my JavaScript console, and see, well, there's no error. So which means that probably that library was loaded correctly. And to test it, I can try to create a vector here, v1 new vector 3, sorry. And I think it worked. So if I print this, I get a vector 3 object. Okay, so if you want to make sure you got your libraries correctly, you can test it this way. All right. Okay, so that's it for the first bullet point. I'm going to go back here to our canvas. That's it for the first bullet point. So you see here that you should get results like this. Now it's your job to go ahead and do the other part, which is the second part is that you have to change this example now to draw a red vector, I'm calling it v1, on a black canvas instead of a white canvas. So in this first example, you get a blue rectangle on a white canvas. What I want in this part is for you to modify that to get this black canvas with this vector v1 here drawn. And this is going to be a hard-coded vector. In this image, I'm showing the vector v1 2.25 by 2.25. Okay, and okay, so here, then if you do number 3, once that is done, which is now instead of drawing a hard-coded vector, we want you to create text boxes and a button here for the user to specify the vector. So then every time the user hits the button draw here, you'll draw the vector that is specified by these text boxes. So you can see a little animation here, different examples. Okay. Once that is done, then we want you to extend that interface to allow the user to draw a second vector in blue, which you can see here the vector v2 now have 2 extra text boxes, the same button, but now when you click the button, you get the 2 vectors drawn. Okay. The next point is now you're gonna actually start implementing vector operations, and for this point, you're gonna have to implement these 4 functions here: add, sub, div, and multiplication. As I mentioned before, this is in here, right, in Quant Matrix CSC 160, and I'm talking about these functions here: add, sub, div, and multiplication. And here are the details on how to implement those. Next point is to implement the magnitude and normalize functions. Um, Actually, just before talking about that, let me just describe how the results should be visualized of the operations, right? If you look at this image here, when you select an operation like divide or add, for example, you see the result in green. So this is the subtraction now, and now I'm going to multiply this by scalar, so I get a longer vector, and we should hit divide and divide it by 2, I get a shorter vector as a result. So the results of the operation should be drawn as green vectors, okay? And note that multiply and divide, they're applied to both v1 and v2. Some of them, add, for example, creates a new vector, right? Creates a new vector. Subtraction has a new vector. Multiplication has 2 new vectors that are scalar, that are they're scaled versions of v1 and v2. The same for divide. So that's why you see when you divide and multiply, you see both v1 and v2 in green here, but you see the original vector and the scaled version. I hope that is clear enough. So for magnitude and normalization, you have the magnitude and normalization functions down here. Okay. Note that to implement normalize, you can use the magnitude function. So I recommend you implementing this first. You implement magnitude and then you use magnitude to implement normalize. Okay. And then similar result here, similar results, but now the magnitude of the vector, you have to print it. So here at this number 3 task, you have to print the result of the magnitude of each vector v1 and v2 on the console, right? So here you see when the user hits draw, you get the outputs, the magnitude of v1 and v2. And so this is a little bit different. But for the normalized operation, you get the normalized versions drawn on top of the regional v1 and v2. You see here the small the small 2 vectors. And remember that a normalized vector is a vector of the same direction but magnitude 1. Okay. And the last 2 bullet points are the dot and cross product. And here you have to implement the dot and cross functions. Those are static functions. But we're going to have to use them. For example, the dot product here, you're going to use the dot product to calculate the angle between the two vectors. In this case, is 90 degrees, right? So here's like a hint on how to implement that. And similar to the previous bullet point, here you're going to print the result to the console. Okay, in this case, the angle of these two vectors is 90 degrees. Okay, so that's why you see 90 here. The final bullet point is the cross product implementation. And we use the cross function to calculate the area of the triangle formed by these two vectors, v1 and v2. And here's like a hint on how to do that. Okay. In this case, the triangles here, the triangle has base 5 and height 5. So the area is 12.5. Okay. And that's it. If you have any further questions, please let us know.